Okay, a little later on the 22nd of January, this is going to be 7C, and this will be the last part of Unit 7 where we're talking about the Earth's magnetic field and the Moon. And today what we're going to talk about are lunar landings. So we sent many missions to the Moon. Most of them were unmanned, but we did send a few that were manned. Apollos 11 through 15. 13 had some issues, so we actually only had 5 moon landings. So we actually is at 6. I think there are 12 people that have actually walked on the surface of the moon of the 7 point. Actually, one of them just died not too long ago, but of the 7.3 billion people, only 12 have walked on the surface. So what did the moon missions reveal? First thing it revealed to us was that there are enormous boulders fractured from mountains. And how'd they get to the surface? They rolled down, sliding down the mountain just like they do here on Earth. And they shattered, just like you can see this one is shattered right here. They don't have any weathering erosion or very little weathering erosion because no atmosphere, no water, no ice thaw. So what basically happens is small meteorites, micro meteorites coming down. They may get a couple other things, so basically these rocks hit the surface and they stay the way they are forever. We also found out that a lot of the moon is covered by this very thin, almost like rock flour, this powdery material. It's called regolith, and that's actually Neil Armstrong's footprint in the regolith, and you can see that it's compressed sort of like he's walking on a dusty surface. And remember, July 20th, 1969, Neil Armstrong, first guy on the moon. Here are the Apollo 11 astronauts. We have Neil Armstrong, we have Mike Collins, and we have Buzz Aldrin. The two sitting are the ones that actually went to the moon, while Mike Collins stayed in Columbia, the command module, and orbited the moon as these two went down on the lunar lander called the Eagle, and actually got to walk on the moon. But that all happened between the 16th and the 24th of July, with them landing, real close to the 20th, almost right in the middle. So here is the command module, Columbia. Here's the lunar lander, Eagle, and they actually separate. I'll show you a graphic in a couple minutes, but they separate soon after they start on their trip to the moon. This is the craft that they're in. They all three sit inside this command module until the two are ready to move into the Eagle, the lunar lander. And then the lunar lander actually has two parts. This part has the actual engine, and then there's a smaller engine in this section. So when they land on the moon, they've done all the things they're going to do on the moon. This part comes back up to the command module. Then this rocket actually speeds it up so it can leave lunar orbit and cruise into the Earth's orbit, and then close to that surface. As it slows it down, this thing is lost, and then all three are just in this command module, the capsule, and looks basically like this. As they get through the atmosphere, two parachutes go up to slow them down. Then they do a water landing because it's a relatively soft. They can compress into it a little bit, so it's a relatively soft landing. And then there are balloons that pop out the top to make sure that it rights itself. And then they actually jump out onto a life raft, and then they're saved by the Navy and helicopters coming down. Here's a picture of, I think this is Buzz Aldrin. This is Apollo 11. They're looking at the Eagle, and you can see the American flag, and you can see some of the instrumentation that they left up there to do moonquakes and to do distances to the moon and other things. Okay, so here is a depiction of the whole trip. You can see they actually take off of Cape Canaveral, and they're using the Earth's rotation this direction to give the rocket extra speed, and it orbits the planet for a little while until it picks up enough speed, and then it jettisons out of the lunar orbit, and then you can see the command module pops off, and it turns around and then it reaches into this second stage and pulls out the lunar lander, which you can see. Actually, you can't see, but they pull out the lunar lander, and then the lunar lander actually moves off this direction. They move in space, and then it spins around so it can fire its engine and slow its speed down. And then what happens is the lunar lander separates, and it drops down as the command module spins around the Earth for about 16 orbits while these guys are down on the moon, and then they shoot off. The top part, the Eagle itself, actually comes up and then meets the command module again, and then they speed themselves up, going around a couple of times, and then they actually spin out, and you can see that they move, and then they turn around and they slow down, and then they separate into the capsule, and then the capsule falls down, and eventually parachutes pop out. And then we have lots of ships out there in other places just in case they don't land where they're supposed to, and then they get rescued, and that's how they do the trip to the moon. Lunar rocks, we had Luna as well as Apollo, and you can see they're pulling in like 3.6 ounces on the unmanned spacecraft, where we were actually pulling out 50, 80, 90, even 250 pounds of rock, even in 1972. So there are the 6 Apollos, 12 astronauts walking on the Earth. Lunar lander actually has the landing section, and then there's the section that they live in for 3 to 4 or 5 days, and then that's the part that actually takes off to go back to the command module. On the moon itself, we found 3 basic types of rock. We had basalt, the dark rock that actually makes up the ocean floor on this planet. This is called vesicular basalt, and it contains many holes that suggest there was gas dissolved in this material, and about 3.16 billion years old. So even the youngest rock on the moon is relatively old. Then we have anathracite. Anathracite is actually in the highlands. It is a highly metamorphosed rock in about 4.4 billion years. And then around the craters where we actually get the pulverization, the shock waves going through, we have crushed rock that's actually put together with other matrix, and these are called breccias. So these are impact breccias, and these are created by high pressure, high temperature created by that space asteroid or meteoroid impacts. So 3 types of rocks: basalts, anthracites, and breccias. Seismic experiments on the moon detect moonquakes. They're not anywhere close to the same size as earthquakes, but they are showing that there probably is a plastic area inside, and it causes stresses on the surface and causes what are called moonquakes. We do find water and ice in the polar areas, in the craters, which I showed you before. And that's really good because if you took just a regular 2-cup bottle of water to the moon, it would cost you $10,000 to get it there. So if you were bringing gallons of water for drinking and other purposes, very expensive to get water to the moon. How did the moon form? We actually think that there was a very large body, about the same size as Mars, called Theia, and it actually came through and sideswiped the Earth. And what it did is it took a lot of crustal material, and you can see the bluish type material that actually makes up the inside of this Mars-sized creature, actually going up into space, spreads up into space, and then very quickly, in the period of just thousands of years, actually makes these, they're not called planetesimals, they're called moonlets, and these moonlets come together to eventually make the moon. This computer simulation shows how this collision actually works, and I'll have to show that in class because you can see it goes from YouTube, and I don't want to get any more conflicts with copyright issues. And I'll probably show you that one in class as well. Remind me if I don't. Here's a depiction of that Mars-sized planet actually coming in and striking sort of at an angle. It didn't destroy us, destroyed itself, and actually gives rise to the moon. Gravitational forces actually lock the moon in what's called a synchronous orbit. And then what this means is that we actually see the same size of the moon all the time in a period of about 27 1/3 days. So if you look at the red and the blue dot, the red dot is actually the side that faces the Earth, and as it orbits, it doesn't orbit going around like this, like we expect it to go. What it happens is it actually orbits so this red always stays on the inside all the way around. So it is a synchronous orbit. All points in its orbit, red crater is visible from the Earth, and the blue crater is not. And the blue crater is never obvious. or observed from us. So what does this mean? It means that the moon rotates on its axis once every time it orbits us. So its day and its year is the same. Now, we do actually get 27 1/3 days for the 360-degree orbit. And if you actually watch this line right here and this line right here, they're parallel. So as the moon goes around and gets back to that location, the Earth has moved to here in a period of about a month. So as the moon gets to that sidereal point, 27 1/3 days later, that is a 360-degree complete orbit. It does take that additional almost 2 days to get to this point, and that's the position of new moon in this location, full moon in this location, and then a new moon back to here, which would happen about a little more than 2 days away from its 360-degree orbit. And we talked about that difference when we actually talked about moon phases. 27 1/3 days to orbit the Earth once, 29 1/2 days to actually make like new moon to new moon or a complete moon phase. We also know that the moon is spiraling away from us at about about 1.5 inches a year, 3.8 centimeters per year. And we know this because we have lasers that actually go off to mirrors that are on the moon, and it takes a little bit longer for that trip to go every year. And this energy that's actually given to the moon comes from the Earth's rotation. So as the moon actually has been moving, it actually slows us down, and we've actually we've slowed down about 6 hours in the last 2,700 years, and we've slowed down even a few days. I think we had like 500 days when the dinosaurs were around, so we slowed down to 365 1/4. Okay, and then what do you think? Who was the first person to walk on the moon, and when did this occur? Neil Armstrong, July 20th, 1969. Do we see all parts of the moon's surface at any one time through its lunar cycle? No, we do not. We see about 54 to 55% because the Earth is being larger. We actually get to see around, as we rotate around, we get to see around its edges. It's called a synchronous orbit. Does the moon rotate? And if so, how fast? Well, yes, it does. It rotates at the same speed it revolves. 27 1/3 days to rotate, 27 1/3 days to revolve. And that's it. Actually, there's one more thing I want to do. I want to go all the way back to the second slide, because I think there was another. I'm going to exit this one. And I'm going to go back to this second slide, and I'm going to bring that back up to you. And there was another one. Why does the Earth experience auroras? It's because solar wind produced by the sun, magnetized high energy beams actually come up, and they get concentrated at the North Pole and the South Pole for those aurora rings. Okay, now I'm going to call it quits. Adios. 13 minutes, almost 13 1/2. For 7C. Bye.